Testing the sound. 1, 2, 3. 1, 2, 3. Testing the sound. I guess this should be working fine. Okay. So yes, what's the goal for today? So, the ultimate goal, I basically want to have a Sudoku generator. And not just any Sudoku generator, I kind of want to have one that understands how humans basically solve Sudoku. So I kind of wanted to be able to generate and understand the difficulty of Sudokus. So if you know how people solve Sudokus, there's a bunch of different approaches you can use. Basically like mini algorithms of how, moving the puzzles forward. So I kind of want the generator to understand like what's the difficulty of the different solving approaches that were employed, and basically give me, like, for example, a number or a category for the generated Sudoku. And I kind of want it to be interactive, so I want to be able to kind of go and prepare like a template for the Sudoku generator, and the Sudoku generator will just spit out the actual numbers that, like for this kind of Sudoku you need to put a 9 and a 5 here for the Sudoku to be actually solvable. But that's kind of the ultimate goal. So okay. Actually, let me set up the stream a little bit more. No, this is actually... Okay. That's better. Okay. So, okay, let's write it down. So, you want to Sudoku generator, then the humans solve Sudoku. I definitely want the generator to support like different special types of Sudoku. So if you think about like killer Sudokus or what they call them, the thermo Sudokus, all these kind of chess Sudokus, like all these kind of variants, I want my generator to support all of them. But of course that's the ultimate goal. So what can we do to get there? So first we kind of need a solver. Because if you think about generating a Sudoku, well, you kind of want to slowly go towards a point where the Sudoku is solvable. And to verify that the Sudoku is solvable, well, you need a solver. Like there's no other way around it. Like you basically just need to iteratively solve Sudokus until you reach a point where, yeah, I have a Sudoku puzzle that's actually solvable. So we kind of need to start with the solver itself before we can start generating Sudokus. And like the first step I want to do is just to have some very basic baseline before doing anything fancy. And the very baseline for having a Sudoku solver is just a very simple backtracking solver. So if you think about it, you can kind of solve Sudokus by just guessing. So the very basic solver, like what you could consider a baseline, is just, okay, like I try to solve a Sudoku by just guessing a number, and if I didn't violate the constraints of a Sudoku, then yay, everything is great. And if I did, then I know that the guess is wrong and I need to go back. So we want a basic backtracking solver. Basically it will make a guess and then check the constraints. It's probably not how you spell that. How do you spell that? Yeah, sure. And if it's wrong, thanks, son. So if it's wrong, we want to go. We want to go back. So basically, remove the guess. And if it's correct, we just continue. So let's try to implement this very basic solver thing. So we kind of need to think about our data structures for this. So if you think about Sudokus, if you think about an empty Sudoku, like you kind of can think about it as like a possibility space. So each of the little Sudoku elements Well, each of them can contain numbers like 1 to 9, right? So each of the squares has this list of possible guesses in them. But we don't really need that for the basic solver. So for the basic solver, what we really just need is really just a two-dimensional array, and that's kind of it. So let's just start with that. Okay. So I will make a structure. I will call Sudoku. It will have a two-dimensional array in it. Of integers. Okay. When I create this, so basically an empty Sudoku, I want it to be just some special number. So let's say we will just use a 0 because 0 isn't present in any Sudoku puzzles. So let's make it just full of zeros. So we want data to be, and of course I did remember the constructors. Size value, okay. So I want it to be size of 9 of std vector int, but the vector int I want to be also size 9. And filled with zeros. Okay. So if I just create a variable with that at this point and print out some of the data, they should all be zeros. Okay, let's see. Let's just quickly run this. Yep. Okay. And just to make sure that this is not like some weird default initialization, let me just do this and check if it's -1s now. And it's not, so I'm doing something wrong. Okay, so where's the problem? I'm pretty sure this is the correct constructor. So this is the size and then the value. Let me quickly check CPP reference. I want to look at constructors. Size and I mean, this should be the correct constructor. Oh, because this is initializer lists are screwing me over. Okay. Let's try again. Yes, okay, so because I was using the curly brackets, this is one of the annoying parts with the standard C++ sometimes. The internal vector was being transformed into, was basically initialized from an initializer list So instead of 9 elements of -1, I was having a vector with 2 elements which were 9 and 1. Cool. Okay. So now I have this basic data structure, and basically on top of this I want to have a backtracking algorithm. So let's just make it a simple function for now. It will get a Sudoku and it will actually take it back, copy. And okay, this will probably blow our stack actually. So let's just make it instead. Okay, I can keep the interface, so but for the guesses we will use std stack, yep. And we want a stack of pairs, or do we actually want triples for this? So okay, what I'm thinking is for the backtracking we want to basically, we need to keep a stack, and the stack will be the stack of our guesses, and we just need to keep the position where we made the guess, right? Okay, so this will be a stack of pairs, and then our main backtracking algorithm will be simply make a guess. Okay, so make a guess and check if the puzzle is still okay. Actually, I do want to get this by reference, or actually let's just use this interface. So we want to see if the puzzle is still okay, and then if it is, we put the guess on the stack and loop. If it's not, then we don't put it on the stack. We try something different. So if this was 1, 2, 3, 4, in this case we want to go back to make a guess. But there can be a situation where if you are making a guess, and let's just say we make the guesses from like 1 to 9, right? If we basically get to the point of making a guess and the last guess was a 9, well then we can be out of guesses, in which case we want to remove the last thing from the stack, basically go like 1 level up. Okay, so let's try to write this in a code somehow. Okay, so this will definitely be a loop, and I'm kind of guessing this will be an infinite loop, because we can't hold to loop until we have either solved the Sudoku completely or we have run out of like all the potential solutions. Right. So we want to basically we want to find the, oh yes, the thing is this we want to do on top of one element of the Sudoku. So that we definitely need like an outer loop that is find an empty space in the puzzle. And then on top of the empty space we want to do the guesses until we either find something that works or it doesn't. Okay. So so this outer loop is basically looping over the empty spaces. So we want to do want to loop over all the elements okay. If we find yes, okay, so if this one is empty, so for our case that's 0. Here we want to do the make a guess thingy. Okay, so to make a guess will be a loop and I'm actually guessing this will be, I will need to refactor this later because this is very deep, which I definitely don't like. So right, let me get some coffee. So here we basically want to loop from 1 to 9. We set the thing to the guess. We call a new function that we don't have yet. So if the puzzle is okay, I want to break out of this loop. But before we break out, we want to record our guess. So we want to say that our guess was in position ij. and we can have a situation where we have gone over all the things and we are still wrong. So after we are out of this loop, we can be in a situation that the loop has ended but check puzzle is actually false. So if check puzzle is wrong, in that case we actually want to break out completely. Okay, so I already see I will need to change this code a bit. So these two loops, actually, I just want to find the first empty thing. So let's just make this a function. It will return a pair of ints. Find empty. Okay, so we will if the if this space is empty, just return make pair ij. So this will find us the first empty thing, but of course we also need some sort of return where we didn't actually find anything. So let's just return -1, -1. So okay, so at the beginning of this thing we want to do yes, so here we want to do the basically the next space we want to guess over. Let me see the return here. So this will be find empty on the current Sudoku that we have. If this is like there's no empty space and our check puzzle, and actually let me just write this for now. Like this. So for now let's just make it true. So if we didn't find an empty space and the check puzzle actually returned true, at that point we actually know that we have solved our Sudoku, because we have a puzzle that's completely filled and it is valid. So at that point we just return the Sudoku we have. So if we okay, this gets interesting. So of course here we can have the other option. So if it actually isn't valid and we have filled all the spaces, that gets more interesting. Yeah, okay. So this will depend a bit on the rest of the code. So for now I will just make it we'll just have it return an empty Sudoku. Okay. So now this entire thing needs to be unindented a little bit. So So we definitely know that at this point, like, this will be a 0 for sure. Okay. And we don't need this one, I think. Okay, let's see. So we make a guess, we check the puzzle. If the puzzle is okay, we put the guess onto the stack and we get out of this loop. So that means that the big loop, the big outer loop, will go to the next iteration. And once it's in the next iteration, yep, we make another guess on the next empty space, so that's correct. But okay, we can have the second thing where, okay, actually, whatever guess we make is just, oh, so that actually should be one layer back, okay, like this. So if we went through the for cycle and we didn't find any guess that actually works, what we want to do is basically erase this space. So this is basically like we are saying, okay, like we are not making guess at this space. And we actually want to pop the stack. So we want to look at what was the last guess we made. And okay, so at this point I basically want to go to like the next value, but it doesn't really work with this for loop. So we will need to change this a little bit. So this for loop should actually go from the like the last guess to the next one. Okay, so we need the loop here for sure. Okay, let's say that instead of when we actually make the guess, we will put this. Okay, so let's make this like this. So basically the top of the stack is the element we are currently guessing about. And basically what we want to do here is the current Okay. So let's go back to our algorithm. I'm starting to confuse myself. So I want to find an empty space in the puzzle, make a guess. If you are out of guesses, I want to go one level back, right. So going one level back is for sure just popping the thing. But the problem is then on the one level back we want to continue making guesses. So in actuality well, okay. So I kind of want to... Let me just write this in recursive way and then I'll write the... I will first write recursive one and then rewrite it into the stack one because this is really confusing me for some reason. So in the recursive one, I want to also have these things. So okay. So if the current puzzle is wrong, I just want to return back. Okay, so if the current puzzle is wrong, I just want to return false. If the current puzzle is okay, I want to find empty on my current puzzle. And then basically make a guess. Right, so make a guess. Okay, let me just write this later. Right, so make a guess and then recursively want to go into the new puzzle. And if I actually manage to do it, I just return back. So basically Yep, so it's basically saying like if this guess was recursively correct, as in all the other recursive invocation actually managed to find a guess that works, then just return back, because at the point we basically have a failed Sudoku. Except I need a terminal condition here, as in if the puzzle is filled, and yeah, so if the puzzle is incorrect, I just want to jump back immediately. If the puzzle is filled and it is, at this point it cannot be incorrect, it can only be correct. So if check puzzle actually returns true, right? So this is the terminal condition. So if we basically end up at a point where the entire Sudoku puzzle is actually filled with numbers, and it is also correct, that's where at the very end of the recursion we just want to jump out with a true value. And here, basically, if we go over this loop and we didn't manage to find anything, that basically means all our guesses are wrong, but not just wrong in this place, but they're also wrong recursively. Because we do call the solve recursively. That means that all of these guesses are wrong, and not just that, there's something wrong with the previous guesses. So at this point we just want to return false, which will make the outer for loop go to the next guess, essentially. Okay, so I just need to write puzzle filled. Okay, writing recursive versions of these algorithms is much easier sometimes. So I want to go over all the elements. Okay. I guess I could have just copied. Sure. Because this is the same thing. And how do we know that the Sudoku puzzle is full? Well, if we don't have any zeros. So we set the return false, and if we didn't find any zeros, then just return true. Okay. And let's just check this one elsewhere for now. Okay, so at this point I don't really have a correct check implemented, but if I call solve recursive, because all the guesses are correct, it should just return Sudoku that's just filled with ones, because on every first guess for the puzzle they will succeed, and every first guess is guessing a 1. So once this runs, I should end up, first of all, the solve recursive should definitely return a true, and to start in 0, 0. Realizing I don't really need these. Yeah, I don't need the indexes at all. Oh, because this actually, well, good that I did that, because that was a bug. Right. So yes, I just want to solve Sudoku. So if this returns a false, you know there's something very wrong. Okay. And otherwise, what do you actually want to do? Okay. Right, we just want to write out the value. J, space after that. I want to make a new line after each row, and the very end I don't need to make a new line. Okay. So I try to solve it. It should return all once, and let's see if that works. It returns all zeros. There is something very wrong, right? Okay. Oh yes, because that was an interesting bug. Okay, so it returns all the ones. Cool. So this part works. So what we need to do now is to actually implement check puzzle. And okay, this gets interesting because like so far we just have a two-dimensional array. And for a basic Sudoku, what we want to do is rows need to be all distinct. So there needs to be numbers 1 to 9 in the rows. Columns need to be all distinct. And also the squares 3 by 3 need also to be all distinct. So, right. So the rows and columns are very easy. Okay. Okay, so the rows. For each row, we need to do we basically need a vector of booleans that's initialized to size of the yeah, let's just make it nice. And okay, we're kind of allowing very weird Sudoku where like the rows and columns don't really line up, but let's just write everything in a very generic way for now. And yeah, I want to initialize it with false. And then I go over the rows, I go over the elements of each row. And I just do the value that I have -1, because we store values 1 to 9 and the arrays are 0 index, so we kind of need to shift it by 1. So the value -1, and I will need another check here. I can already see that. I will just mark it as I have seen this value. But in actuality, if okay, so the tricky part is I actually want this to work. I actually want this to work also for like partially filled Sudokus. So for a fully filled Sudoku, what I want to check is, do I have all the numbers in a row? For a partially filled Sudoku, I want to basically check if I have any duplicates. So I don't want to just do this. I basically want to do, if this is true, that means like some other element in this row already had this number present. So that way I want to return false. Because that's a collision, right? And if I want this to work for partially filled Sudokus, I need this to check whether this is 0, and if it is, I just want to skip over the element. Okay, so we go over each of the rows. In each row, what we do is we go over all of the elements. If the element is 0, we just ignore it because partially filled Sudokus. If there is a collision, right. Actually, we don't even need, yeah, okay. So if we have a fully filled Sudoku, if there was no collision, that is actually equivalent to having all the elements in the row. So here we don't actually have to check if all the elements of the present vector were set to true, because inherently they had, like, it just had to happen. Like, there's no other way around this. Okay, and now we basically want to repeat this thing for the columns. So I just want to switch around this. And okay, now I have a problem because I kind of need to do something very ugly here. Yep. Oh well. Yeah, kind of all of these. This one needs a little bit of a cleanup of the code, because like as I'm writing the code, it's not really relying on the fact that like Sudokus are square. I mean, they don't have to necessarily be, but they at least need to be a rectangle. So basically all the rows need to be same size, all the columns need to be same size. It doesn't necessarily have to be a square. You could kind of have strange Sudokus that are actually rectangular, and it could work. I think they're like 6 by something Sudokus. 6 by 4. Anyway, there are some weird Sudokus that are actually rectangular. I have seen those at some point. But right now I'm kind of writing the code like assuming that like all the rows and columns are independent, which is kind of screwing up some of these loops. But I guess that's okay. So the number of columns is the number of elements in the first row. Let's just make it like that. Yes. And then I go over the columns. So this will be yes, so now I just go over this indeed. No. Yes, like this. No, like this, because this is the number of rows. Yes, I go over all the rows, yes. ij, and this logic should be exactly the same. There shouldn't really be anything different here because I just flipped around my indexes. So I go over all the columns, and in each column I go over the row yes. Okay, so just to see if this actually works, I will not implement the blocks yet. And technically, if I just run it now, it should generate me something. We'll see if it actually generates something that makes sense, and nope. Okay. This is interesting. I have something wrong in my logic then, because this is definitely something that should have not happened with the checking I'm doing. Okay, so let's see. So in each row, I go over the columns. If the element is a 0, I just skip over it. If the thing that's at the element has already been seen, I want to return false. Which will basically pop me out here and tell me that this guess is wrong, and I should go to the next guess. So right, so and if it hasn't been seen, then I just mark it as seen. And I go over the row. If I didn't find a collision, I should just like plop down through this code, like that should be fine. So it kind of makes me think that I made some error down here in the solve recursive. So okay, I think we will need to do a little bit of testing then. So let's just handcraft some small Sudokus. So let's do okay, I will need some more interesting constructors. Okay. For now I will just handwrite it, but this really calls for templates. I'm writing this just to see if my, like basically where the bug in my code actually is. Okay, because now I can just go here and have a very small test Sudoku. That I will just do like 1, 2, 2, 1, which from like the perspective of 2 by 2, if we are not checking the blocks, which we cannot because we don't really have blocks in 2 by 2, should actually be valid. So if this actually returns false, I know there's something wrong with the testing code. Okay. Oops. They don't really need to put in debug, but that's okay. Okay, so the testing code is actually okay on this one. So let's see if we have this like 9999 situation, like how did we end up in that? Okay, so now it returns false, which is correct. Okay, so this makes me think that there's something, so the check puzzle is actually correct. There's something really wrong with my solve recursive. Okay, so what are we doing here again? So if we check the puzzle and the puzzle is wrong, we just return false. That's definitely correct. If the puzzle is completely filled and we check the puzzle and that's correct, we return true. So the solve recursive will return true if it's filled, and then it will propagate up through the recursive chain. if this returns false, which can happen two ways, either the check puzzle returns false, so we have a collision, basically the guess we just made as a collision, or we have tried everything. But if we have tried everything, the problem is this will be a 9, and we want to set it to a 0. Right. Maybe that was it. Okay, this looks much better. And yes, this output looks actually very correct, to me at least. Yeah, so these are basically rotations, except for the last one for some reason. But yeah, I mean, they look correct to me. Let me just move this up a little bit so I don't have to switch it up and down. Yep. Okay, so now obviously there's already like this is not really suitable for actually generating Sudokus, because obviously the first row will always be 1, 2, 3, 4, 5, 6, 7, 8, 9, because that's how our solve recursive works. Like it will just keep going to the next one. And well, if it puts a 1 to the second position, that's not possible, because that would be a collision, so it puts a 2. That's because that's the first possible value that actually doesn't create a collision, and so on. So this is like a very, very regular Sudoku. I mean, it's not a Sudoku yet, because we are not doing the blocks. So let's try to do the blocks now. Okay. So for the blocks, we basically will need to do like an outer loop of 3 by 3, because the blocks, we basically have blocks 3 by 3, and we have 3 of them in a 3 by 3 arrangement in the puzzle. So we will need an outer loop for sure. And now I will just hard code the numbers because, yep. So we need to do a 3 by 3. And then inside of each block, so each of these will identify one block. Inside of each of these blocks, this is actually where we want to have our vector. We want to go, but not a 0. So so this is identifying the row. So the row is controlled by I. So this will be I times 3. Yep, so if I is 0, we want to start at 0. If I is 1, we want to start at position 3. If I is 2, we want to start at position 6. And do 6, 7, 8, right? Going up to I plus 1 times 3. And the same for the columns. J times 3. J plus 1 times 3. Oh, not x, y. Y plus plus. And now I want to do my check here for the collisions, but I need to do it on top of x and y. X and y. X and y. Okay. So now I should also be checking the blocks, hopefully. So at this point, this should actually return a valid Sudoku. Okay, so let's see the rows. First row obviously is okay. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, that's okay. This one 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. Now let's check the columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4, 5, 6. Yes, that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. 1, 2, 3, 4. Where's 5? Yes, 5, 6, 7, 8, 9. Yeah, that works. 1, 2, 3, 4, 5, 6, 7, 8, 9. That works. Okay. And if I'm looking at the other ones, this all seems to work. Okay, let's check the squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. This one is also fine. 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 This one is just okay. So all of these are okay. So we kind of have a solver that can solve a Sudoku puzzle at this point. We should do a little bit of a cleanup. So we have a couple of issues right now. First of all, this piece of code is very hard-coded because I'm just straight up saying like, okay, you know, in this block that's 3 by 3 and I expect 3 of them in a 3 by 3 arrangement. That's not great if you want to introduce some more interesting Sudoku puzzles, or even like if I would just change this to, you know, not 9 by 9 by 16 by 16 Sudoku, I would be basically screwed. So how can we make this a little bit more generic? I mean, one thing that's kind of obvious is, like, if you look at these 3 pieces of code, they very much do exactly the same thing, right? Like, I go over all the elements, I basically check if I have a collision, and like that's what I'm doing. Like, there's nothing more to it. So can we generalize this somehow? I mean, one way to do it would be basically, okay, let's just write the ideas down. And I'm not sure if I will be doing this today, but let's just see. Okay. So let's just call this version 0. We can solve Sudokus. Oh, actually, let me just do. Let me just find some actual Sudoku. Okay. So I have found, oops, just this random Sudoku website, and we can kind of try to do this. So let's just put this data, because they have a show solution button. So just put this data into our Sudoku solver, and let's see if it actually correctly solves this Sudoku. So let me just put this to the side, and I will just create the Sudoku. Okay, so I will probably need to do this completely manually, aren't I? I mean, I guess I could just do this. This should actually work. It will be a little bit annoying because I need to do like these kind of things, but it should work. Okay. So 060 800, oops, 009 0. Zeros. Oops. 2. 0, 6 0. Right. Oops. The next one is 076 104. 009 203 600. Okay. Then 600. Oops, no, 07 40. Ugh. Copying stuff is hard. Okay, and then the last 3 rows. 090 000 230. 006 0 8 0 0 4 0 and then 5 0 0 0 0 4 0 7 0. Okay, so this should be this Sudoku puzzle copied. Let me just quickly check if I didn't make any errors, but I think this is correct. And yeah, remember that zeros basically represent like an empty space for us. 076 104, yes, that's correct, that's correct, that's correct, that's correct, that's correct, and that's correct. Okay, so now let's have a look at the solution. And technically, if we just swap over these things, I don't need this anymore, I don't need this anymore. Okay, if we just do run now, it should theoretically spit out exactly this. Okay, and just like roughly looking at it, this does seem to be correct. So we are indeed solving Sudokus as intended, not just, you know, generating, basically generating Sudoku from like an empty state. So for like the basic Sudokus, this indeed seems to work. And I'm not interested in this website, just like the first result I found on Google. But it looks okay. So, okay, let's call it, we have version 0 done. We can solve Sudokus. Everything is very much hard-coded. So in the cleanup, we need to hard-code things. We could switch to the stack-based solution that I tried initially and kind of failed hard at. Okay, that would be one option to do. And well, we should basically beautify the code, right? One thing I am very much not doing correctly right now is that I'm basically testing my solution in my main. So actually we should write some tests. This will definitely become more useful as we try weirder things. What else? We could definitely use like an stream output operator, so because that will be useful just to print out things. What else could we do that's not like jumping to the big thing? Right, okay, so we need some sort of cleanup of the check routine. The main problem I see there is like the logic right now is very much like duplicated many times over. We could use some form of iterator that would just iterate over a block. that's definitely a thing that would work pretty nicely, because then we can just like go over all the blocks and just get an begin iterator for each of the blocks, just iterate until we get to the end of the block, and if we find a collision, then we found a collision. If not, then everything is okay. So having an iterator would definitely be a solution. Is there any other way we could do this? We could... Okay, this is a little bit jumping the gun, because I did like play with Sudoku solvers a long time ago, like 10 years ago. And what I did then was basically I would construct objects that would basically give me, like, they would watch over the validity of a block. So what you definitely can do is construct an object that's like a block checker, and as you are constructing it, basically have it point to the correct elements in our array. And we can do this dynamically, or we can do it statically, like we can just straight up during compilation, because we basically know, well, right now not, because we are using vectors, but if we actually use std array, which is actually a statically sized array, which is fine for Sudokus, we could actually construct this during the compilation and just have the objects point at the correct memory. So this would be a much more complicated approach. Probably not worth it for now. So, but let's just note it down. So we could have objects that check the state of a block. We could have these for each block. So for each block we would have one object. And they would just point at the correct elements in the arrays. So yeah, I guess we are constructed and we just point them at you are a block over these 9 elements, and since this doesn't change over the time as we are solving the Sudoku or generating the Sudoku, like the blocks stay the same, that's fine. Like, we don't really need to shift this around. It could even be a reference. We don't even have to use pointers, because really this is like the moment we construct it, like, it never changes. Yeah, I think that's kind of what we want to do next. But I think that's enough for this stream, at least for now. We have been at it for, yeah, perfect. It's 90 minutes since the start of the stream. So let me just end the stream right now, and I will be back at some point to resume and try to do a version 1 out of this. Yep, see you later.